If you're having trouble setting up your equations for problem solving with direct variations, I want to give you a couple of notes to help you out. So first of all, you need to know that the wording matters, and the wording is what tells you how to set up your equation. So for example, y varies directly as x means to set up your equation so that y equals k times x. So if y varies directly as x, that means y equals k times x. Let's look at a word problem and see how do we turn words that are not y and x, how do we turn them into the variables y and x in our equation. So remember, y varies directly as x. So if the weight of an object on Earth varies directly as the weight of the same object on the moon, then that tells you what your y and x is. So let's start with looking at the weight of an object on Earth varies directly. So this first part is our y value because y varies directly as x. So the first part is your y. That varies directly as the weight of the same object on the moon. That is our x value. So the weight of an object on Earth varies directly as the weight of the same object on the moon. So y equals kx, where y is the weight of the object on Earth and x is the weight of that object on the moon. Now we have to take the next pieces of information and substitute them in for x and y, respectively. So a 300-pound object would weigh 48 pounds on the moon. So we need to start first by matching up what's the weight on Earth, what's the weight on the moon. So let's say I'm going to highlight in purple for the weight of the object on the Earth. So a 300-pound object is its weight on the Earth. So its weight on the Earth is 300 equals k times the weight on the moon. So I'm going to let the weight on the moon be orange. Okay, so if it weighs 48 pounds on the moon, that is our x value. Okay, so we've taken the weight on Earth, which is the y, the weight on the moon, which is the x, and substituted that in for the direct variation equation, y equals kx. So using this information, using this direct variation relationship, how much would a 65-pound object weigh on the moon? So we're saying if a 300-pound object on Earth weighs 48 pounds on the moon, then how can we set up that same proportion or that same relationship for an object that weighs 65 pounds on the Earth? Okay, so we need to find what is this relationship between 300 pounds on Earth and 400 pounds on the moon. From this equation, we can take and solve for k. So we want to know what is k. Well, to find k, I can simply divide by 48 on both sides. So this cancels, and we have 300 divided by 48 equals k. So let's see if that simplifies. Okay, so 300 divided by 48 is 6.25. That tells me the relationship between x and y, or the relationship between the weight on the moon and the weight on Earth. So now if k is 6.25, I can take this information and rewrite it in our direct variation equation. If y equals kx, and we know that k is 6.25, then I can substitute that in. So this equation now tells me that the weight of an object on Earth is 6.25 pounds times its weight on the moon. Now, using this equation, if I want to know how much would a 65-pound object weigh on the moon, well, if it's 65 pounds on Earth, we said that the weight on Earth is our y value. We're searching for or trying to find x, the weight of that object on the moon. So now we can set up that equation, and to solve for x, we'll divide by 6.25. This will cancel, and we need to know 65 divided by 6.25, and that is 10.4. So the object would weigh 10.4 pounds on the moon if it weighs 65 pounds on Earth. Now I want to show you another way of doing this. The second method for finding this weight of an object on the moon if it weighs 65 pounds on Earth is to set up the proportion that we already know. So we've already talked about y over x. That's the proportion that, or the ratio that maintains that value for any direct variation. So y over x, the y that we had to begin with was 300. So if y is 300 and the x value we started with was 48, then we'd set up that proportion. So if y over x is 300 over 48, then what would be that proportion if the y value was 65? So that's setting up this proportion. 300 over 48 is equal to 65 over how much? And to find that, it's very simple. You may have seen the method of cross multiplying before. That's where you simply take and set up your equation by cross multiplying. So that means we have 300 times x equals 48 times 65. So 300x equals 3,120, and divide by 300 on both sides. 10.4.